Okay, and then another examples of dative covalent bond is another example of compound that form dative covalent bond is the hydronium ion. Hydronium ion is formed from H2O. So because for H2O we have two lone pair of electrons on O, so it can donate, it can transfer, it can share either one of its lone pair with the hydrogen ion that has no electrons. So then they will form. So for these two electrons, it is shared. It is contributed by O only, and then H can use together. Okay. So this is hydronium ion. So for hydronium ions, so hydrogen ion originally no electron in the outermost shell, electron division. And then after that, after forming the dative covalent bond, the hydrogen attain doublet structure, becomes stable too. Okay, another examples here. Example 88.3. So I will do with you because this is difficult for dative covalent bond. So for BF3, so originally, so for F it is octet. So first of all, let us find which species is electron deficient. That means does not have enough electrons. So for here, first of all, for the F, they have 8 electrons in the outermost shell. But for B, it has only 1, 2, 3, 4, 5, 6 electrons in its outermost shell. So this B is electron deficient, okay? And then here N have one lone pair. So now this time in this example, N can use it lone pair to form dative covalent bond with the B atom. So these two electrons will be shared between the two, okay? And then it becomes like this dative covalent bond here. So let us talk about these sentences. So BF3 react with NH3 to form BF3NH3. So only 3 pair of electrons in the outermost shell of boron originally, so not octet. And then the electronic arrangement of an atom of noble gas has not been obtained. So by sharing the lone pair of electrons from nitrogen atom of ammonia, by sharing these two electrons, the boron now can attain noble gas structure. Alright? So this is the final product, NH3BF3. So because B is does not have enough electrons, so it is called electron deficient. So N can share its electrons with B, and now B get the octet electronic configuration after sharing with N. Okay, so another example is carbon monoxide. So as represented by these, complete the electron diagram. So here it is a completed one. So for carbon monoxide, carbon originally 4 electrons, and then O 6 electrons. So for carbon dioxide, monoxide, so two bonds are normally shared. Okay, so originally carbon have 4 electrons in the outermost shell, and O2 6 electrons. So 6 electrons in its outermost shell. For two bonds here, you can see from this diagram. So two bonds have normal covalent bond, and then this is dative covalent bond. So that means two bonds, you need to write one cross-run dots. That means they are normally shared. And then for another one, the last one with the arrow is the dative covalent bond. So both electrons are from O. Okay. So altogether, O uses 4 electrons to form bonds, and then 6 minus 4, that means 2 electrons are at O, the lone pair. And then for carbon, it uses 2 electrons to form bonds, so 2 electrons on its own lone pair. So then after that, you can count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8. And then for O, 1, 2, 3, 4, 5, 6, 7, 8. So both of them can attain noble gas octet structure. Okay, these are the more challenging questions.